Lesson 19, solving one-step equations by adding or subtracting. Our new concepts today focus on the idea that an equation is a statement that uses an equal sign to show that two quantities are equal. Both sides of the equation equal each other. A solution to an equation in one variable is a value of the variable that makes the equation true. So here we're going to begin in example 1, identifying solutions. We want to simply make the statement true. Whenever it has a variable, I'm going to say a variable represents or a number plus the number that's given. So here we'd say a number plus 6 equals 9, or what plus 6 equals 9 for x equals 3. Plug that in. 3 plus 6 equals 9. Is that true? Yep, if you write it out, substitute 3 for x, it's true. Letter B says a number x minus 6 equals 9. What? Take away 6 equals 9. If you plug in 3 for this, 3 minus 6, you don't get 9. 3 minus 6 is actually negative 3, so it's unequal. It's not a solution. So in some of the problems today, you're going to be asked, is this a solution or is it not a solution? If it makes a true statement, as in there's equal signs that are exactly the same, that's true, it's a solution. If it's not a solution, you'd write not a solution. An equation is like a balance scale. Here you want to make sure that the scale is balanced, as in there's the same amount of material on each side. Now what's unique about a balance scale is if you take something off one side and take the exact same thing off the other side, the scale is still balanced. So we're going to use that as we think about how we would go about solving equations to try and make things balanced and then find what the equal is on both sides of the equation. Equivalent equations have the same solution set. By adding or subtracting the same quantity from both sides of an equation remains equivalent to the original equation. Furthermore, each side of the equation remains balanced as the equation is solved. So what we're going to look at today is when we have an equation and there's an operation that's in the equation, you can add or subtract to that operation to both sides of the equation. When you do something to both sides of the equation, it actually keeps the equation the exact same. These properties are called the addition property of equality and the subtraction property of equality. What this means is if you add something to both sides, the exact same thing, you actually have the same equation. So if 2 equals 2, that's true, and you add 3 to both sides, you have 5 equals 5. This is the addition property of equality. If I add something to one side, I add it to the other side. Same thing is true if you subtract. It's called the subtraction property of equality. If I subtract something on one side and subtract something on the other side, the equation is actually going to be equal. If I subtract on one side, I subtract on the other side. Remember those two phrases. You add to one side, you add to the other side, you subtract to one side, you subtract on the other side. You subtract or add by the same thing on both sides. It actually keeps the equation equal. It actually can allow you to solve or simplify an equation by doing so. These are sometimes called inverse operations because in an equation that has addition, you're going to do subtraction, you do the opposite. In an equation that has subtraction, you do addition. In an equation that has multiplication, you do division, and in an equation that has division, you do multiplication. Today we're focused just on addition and subtraction. Your exploration in this activity goes through and uses tiles to model what this looks like. We're going to jump right into solving equations by adding and subtracting in example 2 and example 3. Take a look here. Letter A says x minus 3. Notice this says subtraction. Minus 3, minus 3, minus 3. What's the opposite of minus 3? Well, plus 3. When I see a subtraction sign, I do the opposite, and I do that to both sides. So add 3 to one side, add 3 to the other side. This actually eliminates. Negative 3 and positive 3 are eliminated, and now I have 12 plus 3 is 15. So if you go back and you check your solution, 15 minus 3 equals 12. Yep, that works. Here you'd have your answer, 12 equals 12. In letter B, negative 15 equals n minus 8. I have minus 8, minus 8, minus 8. Anytime that I see its subtraction, I do the opposite. The opposite of minus 8 is plus 8. What I do to one side, I do to the other side. So if I add 8 to one side, I add 8 to the other side, and now I can simplify. Negative 15 plus 8 is negative 7. Now let's check that. Negative 7 minus 8, those are the same sign sum. 7 plus 8 is 15, keep the same sign, and those two check out to be exactly equal. So I solve equations by adding when I have subtraction to start in the equation. Anytime I see a minus sign, I see subtraction, I know that the way to solve that one-step equation is to do the opposite. I add in that case when there's subtraction that's being shown. When do I subtract? Well, it's the opposite. Whenever you see addition in the initial equation, then you do the opposite of that operation. Here in letter A it says k plus 7 equals 13. So you're thinking, what plus 7 equals 13? You might be able to just say in your mind 6, but here's the algebraic expression here, the algebraic way to solve it. It says plus 7, so I do the opposite of plus 7. The opposite of plus 7 is minus 7. Plus 7 minus 7, what I do to one side, I do to both sides. Subtract on both sides. 13 minus 7 is 6, and I find my answer. Letter B, negative 21 equals P plus 9. It says plus 9, so I know I need to do the opposite of plus 9. The opposite of plus 9 is minus 9. And what I do to one side, I do to the other side. I do to both sides. Plus 9 minus 9, those would cancel. Negative 21 minus 9, same sign sum, add them up, negative 30. Now if you go back and check that, you'd find the exact same answer. Negative 30 plus 9 is negative 21. In this case, 6 plus 7 equals 13. Both of those check out to be exactly true. Now the same can be done when you're solving by adding or subtracting with fractions as well. What you need to make sure that you keep aware of when you're adding subtracting fractions is that you have common denominators. So you might need to be able to change the denominator in one of those problems to make sure that you can do that addition or subtraction. Again, the same principle applies. Here you have x plus 4 equals negative 3/8. Plus 4 is your problem. You want to subtract 4. Okay, so plus 1/4 minus 1/4. What you do to one side, you do to the other side. And here's where you're subtracting negative 3/8 minus 1/4. If you have fourths in terms of eighths, this would be 2/8. So if negative 3/8 minus 2/8 equals negative 5/8. It works for decimals, it works for fractions as well when you're doing the opposite addition or subtraction problem. In example 5, you have an application of this. On January 10th, 1911, the temperature in Rapid City, South Dakota fell 47 degrees in 15 minutes. What was the temperature at 7 a.m.? X is the temperature at 7. You have the equation x minus 47. If it says minus 47, you know to add 47. What you do to one side, you do to the other side. So plus 47 plus 47, 8 plus 47 is 55 degrees. That was your temperature in that word problem. The key is being able to set up the equation and then following those steps. When it says subtract, add. When it says add, subtract, and then do that to both sides to simplify the equation. Let's jump in and look at our lesson practice problems next. Practice problems for lesson 19, broken down to match up with the example problems that we just looked at. In letters A and B, we have to take the equation that we're given, plug in the value that we're given for that variable, and see if it makes a solution, makes that equation equal on both sides. Let's take a look. You have h minus 14 equals 2, and it says, well, does this work if h equals 12? What I would do is erase the h and plug in the value right here and then solve the mathematical problem. 12 minus 14 equals 2. Is that a solution? Well, 12 minus 14 equals negative 2. It doesn't equal 2, so I would say not a solution. In letter B, it says negative 11 equals j minus 14. What minus 4 equals negative 11? Thinking to myself, well, does negative 7 answer that question? I'll take the variable and erase it, plug in that number for the variable. Negative 7 minus 4, same sign and sum, add those up. 7 plus 4 is 11, keep the same sign. Negative 11 equals negative 11. Anytime I have it where it's equal, it's going to be considered a solution because we want it to be a true solution. In letters C and D, it asks us to add to solve a one-step equation because you see in both of those equations you've got a subtraction symbol. Anytime you have a subtraction symbol, you do the opposite. So x minus 5, the opposite of minus 5 is plus 5. And then what I do to one side of the equation, one side of the equal sign, I do to the other side of the equation. So plus 5 on this side, plus 5 on that side. 17 plus 5 is 22, so x equals 22. Let's check that math. 22 minus 5, I would have to carry here, turn that into 12, becomes a 7, 17. That checks out to be exactly correct. X equals 22. In letter D, it says negative 30 equals m minus 12. Minus 12 is what shows up right away. Anytime I see that it says minus 12, I'm thinking, well, to solve a one-step equation, I need to do the opposite. So opposite of minus 12 is plus 12. What do I do to one side? I do to the other side. Plus 12 on that side, plus 12 on this side. This side would cancel, so I'm left with just m over here by itself. Then I have negative 30 plus 12. Different, subtract. 30 minus 12 is 18. Keep the sign of the larger absolute value, which was negative. Negative 18 equals m. Let's go back and check. Negative 18 will be plugged in for m. Minus 12, same sign sum, add those up, equals negative 30. Notice how those two are exactly the same. That checks out to be true. So negative 18 equals m is our answer there. That was adding to solve that one-step equation. Now let's check out over here in the subtraction portion. I'm going to subtract each time because here I have addition, addition, and addition. When it says plus 3, I know I need to do the opposite of plus 3. The opposite of plus 3 is minus 3. What I do to one side, I do to the other side. 37 minus 3 is 34. 34 plus 3 is 37. So my answer, P equals 34, would actually be correct. In letter F, I have negative 14 equals y plus 8. It says plus 8, so the opposite of plus 8 is minus 8. What I do to one side, I do to the other side. Minus 8. Negative 14, minus 8, same sign, sum. Add them up. 14 and 8 added together is negative 22. Keep the same sign. So negative 22 plus 8 is going to be negative 14. That checks out to also be a true and equal equation. For letter G, I've got to continue my method of subtracting because I have addition happening in the middle of this equation. However, I have fractions. When I have fractions, I have to make sure that I'm adding or subtracting with common denominators. Let's take a look. To solve for d, I want to get d by itself. That means I use inverse operation. It says plus 4 1/2. I would minus 4 1/2 as the opposite or inverse operation. What I do to one side, I do to the other side. So I would minus 4 1/2 over here. Now I'm going to rewrite this so it makes a lot more sense. This side would cancel out. I have 4 1/2 subtracting absolute values minus 3 1/6. Now I need to change 1/2 into terms of 6. I would multiply by 3 in the denominator here. 3 times 2 is 6. Multiply by 3 on the top, I'd get 3/6. Or knowing that 1/2 equals 3/6 would help me out as well. So now I subtract. 4 minus 3 is 1. 3/6 minus 1/6 is 2/6. If I change that and solve it or rewrite it in terms of simplified terms, it's 1 1/3, and because when I subtracted this it was negative, the answer is going to remain negative. Hope that helps.